Hello, in this video I'm going to solve a problem for you on the topic of Diophantine equations in number theory. In number theory, an equation is called a Diophantine equation in which you are looking for integer or natural number solutions. Usually in these types of equations, the number of unknowns is more than the number of equations. So let me read the problem for you first. Consider the following equation. 3xy minus y minus 5x equals to 13. Solve this equation in the set of natural numbers. So as you see, I have one equation. I am interested in natural number solutions, and the number of unknowns x and y is 2, more than the number of equations that I have. Interpret your solution graphically. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, you will get 3 different solutions for this. The answers are x is 15, y is 2, or x is 4, y is 3, or finally x is 1, y is 9. If you are interested to more problems of this type, you can refer to the following playlist. The link to the PDF file that you see here on the display is in the description below this video. Okay, so now let us solve the problem. The first thing that I will do, I will express y in terms of x as a function of x. But be careful, here in this case I know that x and y are supposed to be natural numbers. So what I will do, between the first two terms I factor a y out, and then I move minus 5x to the right side. It becomes positive 5x plus 13, and then of course because x is supposed to be a natural number, so 3x minus 1 is definitely non-zero, and I am safe to divide everything by 3x minus 1. Yes? Okay. But of course, in this form it is not very useful, even though I know that this is a natural number, so this means that this fraction is supposed to be a natural number. So what does it mean? It means that I demand that 3x minus 1 divides 5x plus 13. Yes, this is what I demand. Okay, but the problem is that this is not easy to be able to find all possible values of x for which the left-hand side divides the right-hand side. The reason is that the right-hand side also depends on the variable x. So it means that it's not a fixed number. This relation, if I want to succeed to be able to solve the problem, the ideal scenario is that I have something that depends on x on the left, but I have just one constant number on the right. For example, let us say that it was like this. Let us assume that 5x was not there. Then, if this is just a fixed number, then I can guess what x can be, because 13 is supposed to be divisible by 3x minus 1. So this means 3x minus 1 is either 13, minus 13, 1, and minus 1. We don't have much more options. We don't have more options than this. Yes? So the ideal scenario for divisibility, if I want to use this idea to solve equations, is the case that I don't have any x dependence on the right hand side. Having said that, so let me clean this. Having said that, I want to write this fraction in a way that only a number, a constant number, remains in the numerator. But of course, on the other hand, I cannot change the problem, so I can rewrite the problem in a different form so that I achieve the goal. To do that, I will multiply both sides by 3. So the left side becomes 3y, the right side, the numerator has 2 terms to be multiplied, so it becomes 15x plus 39, and then I have the denominator as it is. You might wonder why this is useful. Just you see that now 15x is 5 times 3x, and 3x is the term that appears here. So what can I do? I can write 5 times 3x minus 1. Okay, so let us see what I have so far. 5 times 3x is 15x, I have it. But 5 times minus 1 is minus 5, I don't have it, I have 39. So what should I do? I have to add 44 to compensate for that minus 5. And then divide everything by 3x minus 1. But now I copy and paste the left. The right can be decomposed into two fractions. This divided by 3x minus 1 plus 44 divided by 3x minus 1. Yes? But what is the benefit of that? Because now this one and that one are gone. So what I am getting, 3y equals to 5 plus 44 divided by 3x minus 1. Yes? And then, for example, I can move 5 to the left. This becomes 44 over 3x minus 1. Okay, so what we know is that this number should be an integer, because y is a natural number. If you multiply a natural number by 3 and subtract 5 from it, this is definitely an integer. Okay? In most cases, of course, it's a natural number. If y is 1, then it becomes minus 1, minus 2, but if y is 2 or beyond, this becomes a natural number. Anyway, this means that this fraction in general is an integer, so this means that 44 should be divisible by 3x minus 1. Yes, so this happens that 3x minus 1 should divide 44. But because x is a natural number, the minimum value of x is 1, so this is always positive. Okay, so the left hand side is positive and the right hand side is 44. 44 is supposed to be divisible by this one, but we know that 44 is only divisible by these positive numbers: 1, 2, 4, what else? And then 11, and then 22, and finally 44. What is this list? This is the list of all natural numbers for which, so that 44 is divisible by, nothing else. Yes, but can 3x minus 1 be equal to 1? You will see no, because 3x minus 1 equals to 1 means that x is equal to 2/3, but this is not acceptable because this is not in the set of natural numbers, for example. So you know that this is not possible. But is 2 possible? Yes. 2 is possible. Why? Because 3x minus 1 equals to 2 means that x is equal to 1. And 1 is indeed a natural number. But we also have to be careful. If x is 1, then what happens? If x is 1, then 44 divided by 2 becomes 22, and when it becomes 22, so 3y becomes 27. Or we can do that, okay? So let me write it for you. So if x is equal to 1, then 3y minus 5 becomes 22, and then this means that y is equal to 9. So one solution is 1 and 9. Okay, but is 4 acceptable? No, if this is 4, then 3x becomes 5, and again x is 5 over 3, which is not an integer, so let me take that off as well. But 11 is acceptable, because if 3x minus 1 is equal to 11, it means 3x is equal to 12, and it means that x is equal to 4. But 4, what happens? If x is equal to 4, if I put it here, then it becomes, this number becomes 11. 44 divided by 11 becomes 4, so 3y minus 5 is 4, so y is 3. Yes, so 4 and 3 is also another solution. Yes. And finally, you will see that this is not acceptable. This is not acceptable anymore because 3x minus 1 equals to 22. X is not a natural number. And finally 44 is also acceptable. Why? Because 3x minus 1 equals to 44 means that 3x is equal to 45 and then x is 15. But if x is 15, then this number becomes what? 44. And 44 divided by 44 is 1. So 3y minus 5 is 1. So y is 2. So this means that the other answer is 15 and 2. So this is why you don't see any other answers for this. Okay, but what is the graphical interpretation of this? It means that if you draw the graph of this function, there are only 3 points on the graph of this function so that the coordinates are both natural numbers. If I type that equation 3xy, because you know that GeoGebra is also capable of drawing implicit functions, so I don't need to write it as a explicit function. So I just type the equation that I have, minus 5x equals to 13. And these 2 branches are the branches of the graph of this implicit function, I would say. And then the points that we got are just 1 and 9, which is one of them is here. So if I pinpoint this point, that's one of them, it's 1, 9. And the other one is 4 and 3, so it's here. And then the other one is 15 and 2. So I have to move this a little bit to the right so that you can see 15 and 2. As you see, it's here. Okay, 15 and 2. Okay. But of course it was clear that this left branch is useless for us because the left branch goes to the negative values for x, but I'm looking only for natural numbers. And then, of course, even though, I just want you to understand that even though we could see this on GeoGebra, but there is no guarantee that there are no other grid points that lie exactly on the branch, on this branch of the graph. But now that we have solved it analytically, we are completely confident that no, these points A, B, and C are the only points that are on this graph, and they coincide with a grid point exactly. Okay, because grid points are the points with both coordinates natural numbers. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.